Paul, over to you. Thank you.
Thanks very much. I hope you can all hear me okay. Apologies for the technical issues that we had earlier. Yeah, look, let's have a look at green hydrogen in Ireland. Thanks first of all to CIGRE NGN for having me. I'm very excited to be talking about green hydrogen in Ireland, and especially focused on why is everybody talking about this and when is it actually going to happen. But before we dive into the green hydrogen space, I just want to very briefly introduce you to Bord na Móna, because I think it's a very interesting story that we can tell here. So Bord na Móna was founded in the 1930s at the energy crisis, and obviously Second World War was going on as well. So Ireland didn't really have didn't really have energy security. So the Turf Development Board was founded to basically harvest peat and use peat for electricity generation. Bord na Móna was doing that for a long time. Obviously, it has a lot of carbon emissions associated with that, and yeah, the emerging climate crisis basically got Bord na Móna into a position where they said, okay, look, we probably should stop doing that, and we should really focus on something else that is better for the environment. So we stopped harvesting peat. We're actually going to stop using peat as well for electricity generation at the end of the year, and we are fully committed and focused on renewable electricity generation. That transition was actually called from brown to green, so it's kind of it is what it says on the tin, I guess. We have 80,000 hectares of land that we own across the country. You see a map of Ireland here in the middle of the slide. Mainly in the Midlands, but a little bit on the top left. We weren't really sure whether that's an asset or a liability for a good few years, but as it turned out, it's an absolute asset for us to have, because not only can we rehabilitate those lands to turn those peatlands into what they used to be and act as carbon sinks, but also we can develop those lands for, let's say, onshore wind or solar. So at the moment we have a project fleet of 15 plus onshore wind projects under active development. But not only onshore wind, we're also looking at offshore wind. We have a joint venture set up with one of the big players in the offshore wind space, Ocean Winds, and we're actively developing two projects there. That's the Metnamara project on the east coast of Ireland, and then the Celtic Horizon project on the southeast coast as well. But look, I could talk about offshore wind for an hour or two now and the policy environment there, but let's look into green hydrogen, because this webinar is really focused, my part anyway, is very focused on green hydrogen. What I want to start with is basically to explain to you how do we actually produce green hydrogen? What is it that everybody is talking about? So green hydrogen is around for a long time. The process is around for a long time as well, hundreds of years actually. And basically what makes it green hydrogen is if we take renewable electricity and use that electricity in a process called electrolysis, where you split water into hydrogen and oxygen, you can then capture the hydrogen, either store it or use it as a green fuel. The oxygen can either be used as well in industrial processes or just emitted to the air. Now, what makes it green is that the renewable electricity, your first input into the system, it has to be green, it has to be renewable. What you can see on the slide is that there's not a single carbon element involved here, which makes it a zero emission fuel. There's a lot of talk about other forms of hydrogen in mainland Europe and predominantly the US as well, grey hydrogen and blue hydrogen. They're types of hydrogen that where your input is natural gas, and then you basically split the water, you take the hydrogen atom from it, but obviously that has carbon emissions associated with it. In the case of blue hydrogen, you basically capture the carbon then and store that. But as you can see, there is carbon associated with it, so it wouldn't be considered zero emission. So just to be clear, every time I say hydrogen in this presentation, what I'm referring to is green hydrogen. Okay, so now we know how it's produced, but why do we actually need it? What are the benefits of green hydrogen? And where I would like to start here is in the top middle. Ireland has an ambitious target of getting to a net zero electricity system in our energy system in 2050. But the more and more renewables we have on the system, obviously the better. But at the same time, our analysis have shown that we will need a certain degree of thermal generation capacity on the system, up in between 5 to 15%, probably in around 10%. So what I refer to here at the moment is that those thermal generation assets, they're basically turbines that run on natural gas to produce electricity. In order to be net zero, obviously we have to green that gas. So we have to stop using natural gas and we have to use either biomethane or green hydrogen. But it's a key factor in our net zero system. And then on the left, you have the Dunkelflaute events. Dunkelflaute is a German word for basically no wind, no sun. That actually does happen every so often as well. The more renewables we have on the system, um, obviously if there's no wind, if there's no sun, the demand doesn't stop either. So we need something to back that up with. At the moment, we have those gas thermal generation plants that basically just kick in and produce electricity to meet demand. But again, if we run those units on green gas or green hydrogen, it would be zero carbon. And green hydrogen can also reduce the pressure on the electricity grid by locating certain amounts of demands on the system where required. So when the wind blows a lot, let's say, the electricity grid may actually not be able to take it at certain points. So by putting in place a certain demand, which is your electrolyzer, your hydrogen production facility, it could actually help and reduce the pressure on the electricity grid. And then one really important element is the seasonal energy storage. So the first point that I need to make here is that hydrogen, in my personal eyes, doesn't compete with direct electrification. We have to directly electrify anything that we can because it's the most efficient way of doing it. But there's certain things where direct electrification may not be the right way to go for. So for example, when it comes to seasonal energy storage, you have the wind blows a lot more in the winter, significantly less in the summer, but demand doesn't correspond that way either. So we need some form of harnessing that wind and basically then use it in the summer. Battery systems, storage systems, there are very important for the electricity grid and our energy system, but they only store electricity for a couple of hours or maybe up to a day, not into seasonal needs. So converting those electrons to a green gas and using it then back in those thermal generation units to produce electricity can just be is one of the key benefits of hydrogen. We have to align with the EU legislation. The EU is very ambitious, has very ambitious targets for 2030. They're talking about 10 million tons of hydrogen being produced in the EU and another 10 million tons imported. So that's 20 million tons of hydrogen in 2030 in total, which again is a large number. It's very ambitious. When it comes to grid stability, the more and more renewables that you have on the system, wind and solar, they fluctuate a little bit. So at the moment, we have to have a certain number of thermal generation units on the system at all times to ensure grid stability. There's other technologies out there like synchronous condensers that will help here as well, but another option would be to run those thermal generation units just on a green gas that doesn't have any carbon emissions associated with it. Large storage volumes. Look, green hydrogen is a gas. We have a lot of experience when it comes to handling and storing gas. We are very familiar as a society with a gas, so that's another benefit. Curtailed energy is spoken about quite often as well. So curtailed energy is basically any energy when the wind blows a lot and supply exceeds demand, or supply exceeds what the grid can take at that particular node. That curtailed energy would otherwise just be wasted. So we could just use that electricity to generate hydrogen. Now we have to be careful that we are not only talking about curtailed energy on its own for the production of hydrogen, because the business case just doesn't stack up in this case. Energy security, everybody is obviously aware of the geopolitical situation that we are in. Ireland has imported 77% of their energy needs over the last couple of years. So producing our own green fuel will just help Ireland being less dependent on other countries for fossil fuel imports. You can utilize your existing infrastructure, so that's gas pipelines mainly. That can be blending, but it could also be repurposing those for 100% hydrogen dedicated pipelines. It's an emerging industry, though there's a lot of new jobs, a lot of opportunities for local communities as well. And last but not least, very importantly, you can use hydrogen and combine it with the biogenic carbon source to create so-called hydrogen value-added products, or e-fuels. So that's your sustainable aviation fuels, that's e-methanol, that's green ammonia. So it's just a huge opportunity for Ireland as a country also to export it to mainland Europe, where they know, those countries know, the likes of Germany know that they won't be able to meet their own demands. So Ireland can help you. So that's great. So we know now what the benefits are, but what are actually the routes to market? I'm gonna talk you through these very briefly. On the top left, you see road mobility. So there's actually 3 buses in Dublin that are run and operated by Bus Éireann on hydrogen as we speak. So it's a trial period. It's very positive so far, and it's not those urban routes as such. It's those inter community longer routes where hydrogen is of benefit because of long range and short refueling times. Similar enough to coaches. Coaches will probably come live in 2028. We expect very similar trucks. So it's not so much the urban road mobility where you have the luxury of charging times, but it's more so wherever ranges are long and you don't have a lot of time to charge your vehicles. Then there's the hard to abate mobility. That's the aviation sector, that's the maritime sector. Again, that refers to the e-fuels that I spoke about earlier. So there's huge ambitious targets also by the EU when it comes to sustainable aviation fuels, for example. And we really need to start with that sooner rather than later if you want to hit those targets. Those e-fuels also present a huge export opportunity, which is captured there by the next arrow, but also then in the agriculture sector. So I mentioned it briefly there. You can use your hydrogen to produce green ammonia that is then used to produce fertilizer, green fertilizer. The agriculture sector in Ireland is very strong, also needs to decarbonize, has ambitious targets, so hydrogen will help you too. You have industrial processes at the very top. Now, Ireland, in comparison to mainland Europe, doesn't really have such a huge industrial demand because we don't really have steel industry or high temperature glass industry. We have a bit of cement that also needs to be decarbonized, but in comparison to mainland Europe, the industrial demand is probably a little bit lower. You can also then inject hydrogen into the grid. Again, I'm not referring to blending here. That's 100% dedicated hydrogen pipelines where you can then store the hydrogen somewhere and use it for electricity generation in that is then supplied for the industry and for homes as well. If you're injected into the grid and blended with natural gas, it may also be used up to 20% for heat in homes, but that's kind of the pathway that gets criticized the most, I guess, because it's probably the least efficient use of hydrogen. So just to set the policy context, the National Hydrogen Strategy was published on the 12th of July 2023, which is just a couple of weeks ago, and the whole industry was waiting for it for a long time, but it's a very good document. I can only recommend reading it. The strategy outlines basically 3 primary reasons why we need a strategy for hydrogen in this country. The first one is decarbonizing the Irish economy. So again, can't stress it enough. We should directly electrify anything that is possible, but sometimes that is not feasible or cost effective. So by using hydrogen, it just gives us another option there to decarbonize those sectors. Enhancing Ireland's energy security. So that's referring to the 77% of energy imports over the last years. So by producing our own fuel, we just make Ireland a lot more energy secure because we just have to rely less on important fossil fuels. It also creates industrial opportunities. So that's not only the jobs, but also the export market for e-fuels. What I really like about this strategy document that it considers all elements of the entire hydrogen value chain. So it talks about production, it talks about end users, it talks about transport and storage, it talks about safety and regulation, research. So it really covers the whole value chain. This on the left-hand side is probably the most important page of the whole national strategy because it kind of breaks it down into the 4 sections and kind of gives an indication of whether that's going to be a runner or and when that would be. So I'm very, very briefly going to just highlight a couple of points here. On the production side, it focuses on renewable hydrogen, so green hydrogen only. We're not talking about blue hydrogen or grey hydrogen, what I referred to earlier for Ireland. It clearly says that prior to 2030, hydrogen will be produced from grid-connected electrolysis from surplus renewables only. So that's kind of the curtailment piece that I was talking about. And it mentions the 2 gigawatt of onshore wind being dedicated to green hydrogen production in 2030. When it comes to transporting hydrogen, it's very clear. It says, look, and at the very start for pilot projects, it might make most sense to use it in compressed tankering solutions. So that's your road tankers. It's very flexible. But as production expands, it is envisaged that hydrogen dedicated pipelines will become the most dominant transport option. They also mention hydrogen clusters here. This is basically where you produce hydrogen locally and then have your end user co-located as well. In regards to storage, the first point there is referring to this 5 to 15% of electricity generation to be provided by dispatchable generation, what I explained earlier. So it's hugely important there. It says blending can offer a way to kickstart the production, but in the longer term, it's most likely going to be a 100% dedicated hydrogen network, which ties into the European hydrogen backbone. That the EU is working on as well. In the short term, it's going to be small scale above ground installations for storage, but then in the longer term, hydrogen is going to be stored either in geological stores such as salt caverns or as an e-fuel, which I explained earlier. And then the really important piece then, I guess, is the end user. So again, I mentioned a couple of times now, directly electrify wherever we can, but there is a couple of end users where it may not be most feasible. So those 4 key elements are the heavy goods transport, dispatchable flexible electricity and long duration energy storage, decarbonizing industrial processes, and the e-fuel sector for maritime and aviation. So the last minute I want to just spend on Bord na Móna's plans and how our projects align with the natural strategy that was just published there last week. So in phase 1, that's our pilot project. It's a 2 megawatt electrolyzer at our existing Mount Lucas wind farm. The wind farm is 84 megawatts, so it only takes a tiny little chunk of the electricity generated. We got planning consent for that project in May 2023, which made it the first green hydrogen project to get planning consent in the Republic of Ireland. We are starting construction very shortly, and we're hoping to be producing green hydrogen in 2025, which again would make it the first green hydrogen project in the Republic of Ireland. The hydrogen that is produced on site will most likely be used in the mobility sector, again, because it's the most mature market at the moment. That project is looking to produce about 200,000 kg of hydrogen per year and would result into significant CO2 savings if it was to replace diesel. In regards to phase 2 and 3, what we are looking at is the whole e-fuel production side of things. That's both onshore and offshore. Offshore obviously being phase 3, so a little bit further out, but also producing hydrogen and injecting it into a dedicated hydrogen pipeline in the northwest potentially, but also integrating hydrogen as part of our energy park where you basically co-locate a lot of elements when it comes to energy production. That's basically what I want to wrap up with as well, is basically to introduce you to the Bord na Móna Energy Park concept. Again, I touched on it there. So it's the co-location of wind energy, solar energy, battery energy storage, your end customer crucially. So that could be a distribution center, that could be a data center, anyone who needs a lot of electricity, and we can incorporate hydrogen there. So basically using some of the electricity that is produced on site, producing hydrogen, storing it, and then using it for backup generation for the data center potentially, or using it to fuel those trucks for a distribution center. I hope that kind of gave you a good sense of where we are in Ireland when it comes to green hydrogen production and what Bord na Móna is planning to do in the